Fine students, so in the previous class, so there are two solutions for a transportation problem. First one is initial solution and second one is optimal solution. So to get to the initial solution, there are three methods described in your syllabus. So out of those three methods, first one is northwest corner rule. So in this class we are going to discuss about the northwest corner rule. So let me write here north west corner rule. So northwest corner rule, so also called as NWCR, northwest corner. So how the northwest corner rule is going to work will be explained by me in step by step. Right? So the step number one is, so first of all we need to understand why we need to use this northwest corner rule. So to get the initial basic feasible solution for transportation problem, we are solving northwest corner rule here. So starting with the cell at upper left corner. Upper left corner. This is called as northwest. This is called as northwest of the transportation matrix. So what do you mean by this transportation matrix? Fine, I think in the previous classes we have formulated the mathematical formulation of transportation problem. I will repeat, we have formulated the mathematical formulation of transportation problem. In that we have represented the transportation problem in a matrix form. So when we implement the given transportation problem in a matrix form, then we are supposed to solve that matrix form of transportation problem by using northwest corner rule. So once it has been implemented mathematically, the given transportation problem, what we need to do, we have to start with the cell. Which cell? Upper left corner. I need to say upper left corner means this corner. Upper left corner, right? This corner. So that corner is called as northwest corner. That corner is called as northwest corner of the transportation matrix. Fine. We allocate as much as possible so that either the capacity of first row is exhausted or the capacity of first column is exhausted. That is x11 is equal to minimum of a1 comma b1. So to understand this, first we should know the mathematical formulation of transportation problem. So once we know the mathematical formulation of transportation problem, here it is. So this is what the mathematical formulation of transportation problem. If you remember, so please open this one which I have written in the notes. So check into that one. So it is what? Minimum of A1 and B1. So A1 is what? The first row, whereas B1 is first column. So which is minimum? A1 is minimum or B1 is minimum? Fine, whichever the row or column is minimum, that will be considered here. Fine, that's why they have said what? So that either the capacity of the first row is exhausted or the capacity of the first column is exhausted. Means what? If the row, that is A1, contains a minimum value, so that will be exhausted. Means it will become 0. Means what? This is subtracted with this one. Fine. So what happens if B1 is minimum? Definitely the first column will get exhausted. So whichever is minimum out of A1 and B1 will get exhausted. Fine. So step 2. So in step 2, what happens if B1 is greater than A1? Fine. What happens? B1 is greater than A1. We move down vertically to the second row and make the second allocation of magnitude, that is x22 is equal to min A2 B1 minus x11 in the cell 2, 1. Fine. What happens here? If B1 is greater than A1, means what? B1 is large compared to A1. So we have to move vertically. Means what? To the down. That is to the second row, first column. That is, we have to move down vertically to the second row. Fine. And make the second allocation. Fine, sir. Fine. So we have to move down to the second row, first column.